This is AP Calculus AB. We're on Notes 5.5, talking about particle motion again, finding net and total distance. The graph below represents the velocity v of t, which is measured in meters per second, of a particle moving along the x-axis. So let's label this vertical axis, velocity, and let's label this horizontal axis, time. And this is in seconds, and the velocity is in meters per second. At what value of t does the particle have no acceleration? Zero acceleration and no acceleration are different things. No acceleration means that the acceleration is undefined. For the acceleration to be undefined, that means the velocity's derivative has to be undefined. So when does this happen on the interval from 0 to 10? Well, if we're talking about the derivative, we want to figure out of the velocity, which this function is, when is the derivative undefined? It's undefined at corner points or cusps, and we have 4 of those corner points. So we could say v of t has cusps at t equals 1, t equals 3, t equals 6, and t equals 8. This is on the interval from 0 to 10. The conclusion we can make is that a of t, the acceleration, is undefined at these values. Once again, a of t is the acceleration, which is measuring how the velocity is changing. It's the derivative of velocity. The derivative is undefined at those points, at those x values. Therefore, the acceleration, which is the same as the derivative of the velocity, is undefined. Pardon me. Express the acceleration as a piecewise defined function on the intervals from 0 to 10. So we have 1, 2, 3, 4, 5 pieces. So my acceleration function is going to be defined in 5 locations. I'm just going to put lines here. 1 location, 2, 3, 4, 5. This just to keep me organized. I'll probably end up erasing these lines when I'm done. So the first interval is from 0 to 1. Second interval is from 1 to 3. Third interval is from 3 to 6. Fourth one is from 6 to 8. And the final interval is from 8 to 10. Notice how I did not include any of the numbers where these two come together, because we're talking about acceleration. Those derivatives are undefined. There is no acceleration at those locations. So how do we define A? Well, it's the slope. This is a line, it's a linear part of a graph. It goes up 3 and to the right 1. So in this first interval, A is defined as 3, and that is from 0 to 1. Slope here, looks like we're going to go down 6 and to the right 2. That means we're going to have a slope of -3 on the interval from 1 to 3. From 3 to 6, it's horizontal, so the acceleration is 0, slope is 0. From 6 to 7, we're going up 6. I'm sorry, from 6 to 8 and to the right 2, so the slope is 3. And then from 8 to 10, we're going down 3 and to the right 2. So the acceleration is negative 3 over 2. So here is our piecewise defined function of a of t. For what values of t is the particle moving right, left? Justify your answer. Let me just bring this down here so I can see it better. All right. Hold on a second. Let me crop this a little bit. Okay. Well, for the function to be moving right, the velocity has to be positive. The velocity is positive all through here. The velocity is positive all through here. In these locations, the graph is going to the right. It's going left when the velocity is negative, and it's negative down here. This location, we are going left. So how do we write that formally? Well, we could say that v, I'm going to end up moving this graph because it's going to be in the way. V of t is greater than 0 on the interval from 0 to 2, non-inclusive, because 0 and 2, tell you what, let's use, yeah, that's fine, from 0 to 2. And it is again from 7 to 10. What conclusion can we draw from that? Particle is moving right on those intervals. And then similarly, we could say v of t is less than 0 on the interval from 2 to 7. And therefore, the particle is moving left on this interval. Hopefully that makes sense. We justified our answer with saying the velocity was positive or negative, and we named the intervals for where that was happening. So it says the values of t. So yeah, that's fine. The reason I was hesitating is you could also write this like this. I'm not sure if one's better than another. Find the average acceleration of the particle from 1 to 8. Well, to find the average acceleration, we're going to take the velocity at 1 minus the velocity of 8 over 1 minus 8. If you look at our graph, the velocity at 1 is 3. The velocity of 8 at 8 is also 3. So we're going to have 3 minus 3 over negative 7, which is 0, over negative 7, which is 0. You must use proper units, even if it's 0. So what units did we have for this? Velocity was in meters per second. Time was in seconds. So this is in meters per second squared. It's the average acceleration. That concludes the first video of these notes. We will do 2 more, hopefully, and hopefully that you're understanding. If you don't, drop me a message, ask me a question in class. Peace in the Middle East.